In the video you saw some motions. These motion are examples of a special type of motion called projectile motion. Let's discuss it in detail. Projectile motion. Motion in two dimensions under gravity is called projectile motion. Properties of projectile motion. Projectile motion is a type of motion experienced by an object that is thrown, launched, or dropped and moves through the air under the influence of gravity. After the initial force that launches the object, air resistance is negligible and the only other force that object experiences is the force of gravity. The object is called a projectile, and its path is called its trajectory. Projectile motion involves two components of motion: horizontal motion, which is linear, and vertical motion, which is accelerated due to gravity. An object that experiences projectile motion follows a curved path influenced by the gravitational force. The most important concept in projectile motion is that the horizontal and vertical motions are independent, meaning that they don't influence one another. We can analyze them separately. To do this, we separate projectile motion into the two components of its motion, one along the horizontal axis and the other along the vertical axis. This motion is studied by mathematical equations. The key concepts in projectile are velocity, acceleration, projection angle, maximum height, time of flight and range. Projection angle is the angle between the projection direction and horizontal. Range is the maximum horizontal distance covered by the projectile. Projectile motion has numerous applications in real-world scenario like sports, military defense and space exploration.
Let a projectile is thrown with velocity v0 making an angle theta from horizontal. The horizontal and vertical components of velocity are, vx is equal to v0 cos theta, and vy is equal to v0 sin theta. Now we derive equations for maximum height, time of flight and range for projectile. Maximum height. Maximum vertical distance reached by projectile from projection level is called height of projectile. Height is related to vertical component of velocity. The vertical component of velocity gradually decreases and at highest point of the path becomes zero, as you see. To find maximum height we use third equation of motion along y-axis. So maximum height is equal to v naught square sine square theta by 2g. Equation for time of flight. Time taken by projectile to go from point of projection to point of impact is called time flight of projectile. To derive equation for time of flight, we used second equation of motion along y-axis. After complete flight, vertical displacement is 0, so Sy is 0. So time of flight equal to 2v naught sine theta by g. Range of projectile. The maximum horizontal distance covered by a projectile is called its range. To derive equation for range, we use equation S equal to Vt along x-axis. So range equal to v naught square sine 2 theta by g. Now for maximum range. Range is maximum at 45 degrees. Two projection angles for the same range. For complementary angles, the range is same. For example, at 20 degree and 70 degree, 40 and 50, 10 and 80 and 30 and 60 degree.